Okay, so Assalamualaikum and hi everyone. So in this video, we are going to continue our discussion in chapter 3, periodic table, for subtopic 3.2 periodicity. So for periodicity, okay, we will discuss across a period, okay, and then going down the group, okay, as we going down the group, the trend, okay, periodic trend or pattern as we across a period and going down a group. So periodicity, we will discuss in terms of atomic radii, ionic size, and electronic series. So what is atomic radii or atomic size? So the size or radius of atom is difficult to be defined exactly because the electron cloud has no clear boundary. Okay, dia tiada sempadan yang jelas. So to solve this, the atomic radius is taken as half of the distance between the nuclei of two adjacent identical atom. Jadi di antara dua ni, okay, in between, so we divide by 2. So this is the radius of atom. Okay. Two factors that affect the atomic radii. Ada dua faktor yang mempengaruhi. Okay. First one is effective nuclear charge, or we always write it as ZEFF, okay, felt by the valence electrons. Valence value of the principal quantum number of the valence electrons, which is also known as a screening effect, okay, kesan penskrinan, and variation in atomic radii. So across a period. So this is the trend, okay, variation of the atomic radii as we across a period. Atomic radii of representative element. Okay, representative element means unsur kumpulan perwakilan, okay, which is 1A, okay, group 1, group 2, group 13, okay, group 14, group 15, group 16, and group 17. Okay, so this is the atomic radii. Okay, atomic radii decreases as we going down the as we across a period. Maksudnya daripada kumpulan 1 pergi kumpulan 17, size semakin kecil. Alright, and then the effective nuclear charge. Okay, effective nuclear charge. Effective nuclear charge is the nuclear charge that actually felt by an electron because of the nucleus attraction. Okay, disebabkan oleh tarikan nukleus. Value of ZEFF is the net positive charge experienced by valence electron. Okay, dia merupakan nilai, okay, charge positif bersih yang dirasai oleh electron valence. So ZEFF is given by Z minus S, which is Z is proton number, S is number of electron in the inner shell. Okay, so kita akan tengok the example later, okay, for the calculation. So let's say this is a phosphorus. Okay, phosphorus ada 15 valence electrons. Sorry, 15 proton. Okay, so 15 proton and 15 electron untuk neutral. Okay, so the valence electron is 5. Because ini, this is the valence electron. 1, 2, 3, 4, 5. Okay, 5 valence electron. So electron in the inner shell, okay, electron in the inner shell, this one, 2 plus 8. Okay, 2 plus 8 is 10. Jadi 15 minus 10 is positive 5. Jadi the charge, okay, effective nuclear charge is positive 5. Okay, next, this is the example. Okay, kita tengok calculation bagaimana kita kira untuk magnesium, aluminium, silicon, and phosphorus. So magnesium ada 12 proton, Z is 12 minus 10 electron in the inner shell. So this is the electron in the inner shell. Jadi 12 tolak 10 positive 2. So this one is 13 minus 10 positive 3. 14 minus 10 positive 4. 15 minus 10 positive 5. So ini adalah ZEFF, positive 2, positive 3, positive 4, positive 5. So effective nuclear charge, okay, semakin kuat effective nuclear charge, okay, it is said to be that the size becomes smaller. Okay, alright. Variation of atomic size across a period. Across a period, number of proton increase, the effective nuclear charge increases, nucleus attraction towards valence electron becomes stronger. Jadi tarikan nukleus terhadap valence electron jadi semakin kuat. Thus the size of atom decrease. Variation in atomic radii, okay, going down the group. Jadi bila kita going down the group, dia lain sedikit lah. Kita boleh nampak di sini, the size become bigger. Atomic radii increase. Kenapa dia increase? Because, okay, screening effect ataupun shielding effect ni adalah electron are attracted by the nucleus but repelled by other electrons. Thus, electrons shield other electrons from attraction of the nucleus. Jadi, elektron ini dia akan melindungi untuk ditarik oleh nucleus. Thus, the shielding effect is decreased in attraction between an electron and the nucleus in any atom. Okay. Variation of atomic radii going down the group and value of n. Okay, dengan screening effect. As we going down the group, bila kita turun kumpulan, number of shell increase, okay, and increase. The greater the number of shell, jadi semakin banyak nilai, besar nilai shell. The electrons in inner shells shield the electrons in outer shell from the nuclear charge. Itu kita panggil screening effect. Jadi elektron dekat inner shell ni dia akan melindungi elektron di petala luar, okay, daripada nuclear charge. So dia dipanggil apa? Screening effect. Screening effect akan bertambah. Bila screening effect bertambah, nuclear attraction towards valence electron become weaker. Okay, nuclear attraction semakin lemah. Jadi size of atom akan increase. Okay, disebabkan screening effect increase going down the group. Okay, alright. So the value of n increase, jadi size of atom also increase. This is because nucleus attraction semakin lemah, okay, become weaker. Variation in atomic radii, okay, across the first row of transition elements. Untuk transition element, okay, transition element di tengah-tengah tu, the atomic radius of elements are fairly constant, which is almost same. Dia tak banyak berubah lah kalau untuk atomic radii. So kita boleh tengok dekat sini, dia ada besar, kecil sedikit. Besar dan kecil ni sebab dia is depend kepada dia punya attraction. Okay, kita tengok dia punya effective nuclear charge. Okay, kalau kita tengok dari segi calculation, okay, calculation di sini untuk SC, okay, Z dia 21, initial dia 19. 21 minus 19, positive 2. 22 minus 20, okay, positive 2. Okay, so nampak tak dekat sini, effective nuclear charge dia remain 2. Okay, tidak berubah. Jadi kalau dia tak berubah, that's why dia punya radius, okay, radius dia almost the same. Tiada almost no change lah. Sebab apa? Because of dia punya effective nuclear charge is the same. Kita menolak nombor yang sama. Okay, kita tengok dekat sini. Okay, kalau 30 tolak 28. Okay, 29 tolak 28. 28 tolak 26. Okay, electron in the inner shell ni kita tengok dekat sini. Okay, electron in the inner shell. Jadi ini adalah orbital S for S2. Okay, 3d10 for S2 untuk zinc. Jadi electron is added to the same shell, inner 3d. Jadi number of electron in outermost shell for S remains the same. Jadi bilangan elektron, okay, untuk outermost tu masih lagi berapa? 2. Okay, yang bertambah adalah dekat D ni. Okay, dekat orbital D, di tengah-tengah tu. Jadi the outermost shell electron, okay, experience a similar force of attraction to the nucleus. Okay, the increasing number of protons in nucleus is offset by the extra screening due to increasing number of 3d electrons. Hence, the atomic radius of elements are fairly constant, which is almost the same. Okay, sebab apa? Sebab dia menolak 2. Okay, dia punya positive 2. Jadi maksudnya dekat sini dia tolak yang ini, initial initialnya dia tolak yang dekat sini. Okay, yang saya bulatkan ni. So yang tinggal ni dia masih lagi 2. That's why kalau kita tengok dia punya charge dia. Okay, effective nuclear charge dia masih lagi 2. So among cation and its corresponding atom. Okay, jadi cation dengan corresponding atom, okay, lithium, sodium, potassium, rubidium, cesium, okay, dia akan increase. Okay, kalau untuk cation pula, okay, dia akan radius dia juga meningkat. This is because atomic radius lebih besar daripada cation. Cation. Kenapa? Sebab cation dia hilang elektron. Bila dia hilang elektron, okay, cation hilang elektron, jadi size dia menjadi semakin kecil lah. Okay. Cation versus its corresponding atoms. Cation form when an atom loses electrons. When electrons are removed from valence shell, bila kita buang elektron daripada valence shell, the effective nuclear charge increase, or the number of protons become higher than electrons. The nucleus attraction towards the remaining electrons becomes stronger. Cations are smaller than the atom from which they are formed. Okay, right. So the next one among anion and its corresponding atom. Anion ni maksudnya yang kita tambahkan elektron. Jadi kalau kita tengok F dengan F minus, F is bigger, Cl and Cl minus, chlorine and chloride, chloride is bigger radius, bromine and bromide, bromide is bigger radius, iodine and iodide, okay, iodide is bigger radius. Okay, so yang atas tu anion, yang di bawah ni adalah atom. Okay, so anion versus its corresponding atoms. When electrons are added to an atom, the mutual repulsion between them increase. This causes the electrons to push apart and occupy a larger volume. Okay, jadi dia akan menolak dan menghasilkan isi padu yang lebih besar. So therefore, anion are larger than the atoms from which they are formed. Okay, anion ni lebih besar daripada atom. Okay, di mana dia terhasil. Alright, so the next one is isoelectronic series or isoelectronic species. Okay, isoelectronic came from the word, okay, iso sama, electronic meaning that electron, jadi sama elektron. Isoelectron dia mempunyai bilangan elektron yang sama. Sebab apa? Sebab dia sudah buang elektron. Bila dia buang elektron, dia tinggal bilangan yang sama. Okay, jadi kita tengok dekat sini. Untuk isoelectronic series, proton number tak boleh berubah. Proton number dia tetap akan meningkat. Macam sodium 11, magnesium 12, aluminium 13, silikon 14. Jadi as the number of proton increase, okay, effective nuclear charge also increase. But the nucleus attraction towards the valence electron becomes stronger. Jadi size of ion decreases. Okay. And then magnesium, sodium, magnesium, aluminium, and silicon ion. So proton number is remain the same. 11 minus 10. Okay. 11 and electron is 10. Magnesium 12, electron 10. Aluminium 13, electron 10. Okay, silicon 14. Okay, and then electron dia, proton 14, electron 10. So the number of proton increases from sodium to silicon. This is because effective nuclear charge increases from sodium to silicon. Okay, nucleus attraction towards valence electrons becomes stronger from sodium to silicon. Jadi semakin kuat daya tarikan, dia punya size become smaller. Okay. The size of ion decrease from sodium to silicon plus 4 plus. Okay, so ini adalah the size. Sodium yang paling besar, magnesium, kemudian followed by aluminium and silicon. Okay, alright. So ini adalah untuk isoelectronic series. Okay, so end of chapter 3.2. Okay class, thank you and goodbye.